Lesson 8, Sampling and Sampling Distribution. In this lesson, we're going to learn about how to get samples from a population. First, let's talk about random sampling. Random sampling is a sampling method of choosing representatives from the population wherein every sample has an equal chance of being selected. Random sampling is essential if you want to get samples from a population without biases. There are four types of random sampling. The first one is simple random sampling. It is the most basic random sampling wherein elements are usually represented by a number that are written on equal sized and shaped papers, and then selection of samples is possible through the lottery method. Drawing a number of paper is based from the desired number of sample. As you see in the figure, if you want to get samples using simple random sampling, you will use the lottery method. Write the names or numbers of your respondents and then draw a sample from them. As you can see, this gives your respondents equal chance of getting selected. The second type of random sampling is the systematic random sampling. It is a random sampling which uses a list of all the elements in the population, and then elements are being selected based from the kth consistent intervals. To get the kth interval, you divide the population size by the sample size. For example, in the figure, the total number of population in the figure is 12, and we want to get 4 samples from the 12 respondents. So, to identify the interval, we divide 12 divided by 4. The answer is 3. So we get our sample every third from counting. So here in the figure, we started with the second respondent. That's our first sample. And then we count 3 from the second. So 1, 2, 3. The next sample is the fifth respondent. And then you count another 3, and your next sample is the eighth respondent. The process goes on until you come up with the desired number of samples. The third type of random sampling is the stratified random sampling. It is a random sampling wherein the population is divided into different strata. Selection of samples will be proportionately randomly picked in each stratum. That is why all strata have representatives in forming the samples. For example, in the figure, our population composes different types of shapes with different colors. If we want to use stratified random sampling, we divide these colors and shapes into groups known as strata. Hence, the second step is we have 3 groups. The first one are the cubes. Next, we have the triangular prism, and we have the sphere with their corresponding colors. And to get our samples, we randomly pick the representatives for our samples from each strata or from each group. This is how stratified random sampling is done. The fourth type of random sampling is the cluster sampling. This is a random sampling wherein population is divided into clusters, and then the clusters is randomly selected. All elements of the clusters randomly selected are considered the samples of the study. So, in this type of random sampling, we also divide the population according to groups or clusters that we want them to have. We can divide a population according to gender, or according to height, weight, or even according to their favorite color or favorite food. Now, for each clusters, we randomly pick one cluster or one group, and whichever group is selected, all the members of that cluster or that group will be considered as our samples. Now let's try and identify the random sampling used in each of the following situations. A researcher writes the name of each student on a piece of paper, mixes the papers in a bowl, and draws 7 pieces of paper. This situation represents simple random sampling because the samples are randomly picked using the lottery method. Next, a researcher selects every 7 students from a list. This represents systematic random sampling because we're using the 7th interval and we're getting samples every 7 students. Next, a researcher tells the class to count off and then selects those numbers that are multiple of 7. This type of random sampling represents systematic random sampling still because we have an interval here of 7 and we pick samples every multiple of 7. Next, a researcher separates the list from boys and girls, then draws 7 names per each gender. This type of sampling represents stratified random sampling because the population here is grouped into boys and girls, and then from those gender we get samples each gender. Next, a researcher surveys all students from 3 randomly selected classes out of 7 classes. This situation represents cluster sampling since we have 7 classes, and out of those 7 classes we randomly pick 3 classes, and all the members of those classes are our samples. Let's go to parameter and statistic. A parameter is a value that describes some aspect of a population. A parameter may be very difficult to determine, if not impossible, especially in a large population. This is where samples and statistics come into play. However, a parameter can be determined in a very small population, where every individual can be located with absolute certainty. For instance, in a totally captive population. In this case, you can calculate a parameter directly if all individuals can be located and measured without missing a single individual. But basically, parameters are data that we get from our population. Now, a statistic is a value that is an estimate of a parameter. A statistic is based on a sample. It is calculated from a sample taken from a population. Sampling is a way to collect information or data about a population without actually counting or measuring every individual in the population. Sampling is often necessary since it is often impossible to measure or count every individual within a population, since populations are often large and it may be hard to find every individual. Basically, we just have to remember that statistic is a data that we get from a sample. To understand further, let's compare parameter and statistic in this table. First, let's have parameter. Parameter is a descriptive measure of a population, while statistic is a descriptive measure of a sample. Now, parameter is an actual value in the population, while statistic is the estimate of a value in a population. Parameter is not always possible to measure, especially when you're dealing with large populations, but statistic is always possible to measure. A parameter average or mean is indicated with the Greek letter mu, while statistic average or mean is indicated by bar x. The variance of a parameter is indicated by sigma square, while the variance of a statistic is indicated by the symbol s squared. The standard deviation of a parameter is indicated by the Greek letter sigma, while standard deviation for statistic is indicated by the small letter s. For the total size of population in a parameter, it is indicated by the capital letter N, while the total size of a sample statistic is indicated by a small letter n. Let's go to sampling distribution of means. A sampling distribution of sample means is a frequency distribution using the means computed from all possible random samples of a specific size taken from a population. These are the steps in constructing the sampling distribution of the means. Step 1. Determine the number of possible samples that can be drawn from the population using the formula number of samples is equal to n factorial over r factorial times n minus r factorial, where n is the size of the population and r is the size of the sample. Step 2. We need to list all the possible samples and compute the mean of each sample. And step 3. Construct a frequency distribution of the sample means obtained in step 2. Let's try this example. A population consists of the numbers 2, 4, 9, 10, and 5. List all possible samples of size 3 from this population and compute the mean of each sample. Let's follow the 3 steps for our solution. Step 1. we need to identify the total possible samples that we can get from our population. So we use the formula. The number of samples is equal to n factorial over r factorial times n minus r factorial. Our n represents the number of our population, so that is 5. And our r represents the sample size, so our r is 3. So we substitute. N factorial is 5 factorial over 3 factorial times 5 minus 3 factorial. We simplify, subtract 5 minus 3. Our number of samples is equal to 5 factorial over 3 factorial times 2 factorial. If you are not familiar with the factorial notation, here is a brief description of a factorial notation. If n is a positive integer, n factorial is denoted by n with an exclamation point, is a product of all positive integers less than or equal to n. So it is defined by n factorial is equal to n times n minus 1 times n minus 2 times n minus 3 and so on and so forth until you reached 1. As a special case, 0 factorial is equal to 1. For examples, you have here 5 factorial is equal to 5 times 4 times 3 times 2 times 1 is equal to 120. Going back to our solution, 5 factorial is equal to 5 times 4 times 3 times 2 times 1 over 3 factorial is 3 times 2 times 1 times 2 factorial is 2 times 1. So simplify. 5 times 4 is 20 times 3, that's 60. 60 times 2 is 120 times 1, 120. Now, 3 times 2 times 1 times 2 times 1 is equal to 12. We divide 120 divided by 12 is 10. Hence, we can conclude that we have 10 possible outcomes from our problem. For step 2, we will list the possible samples with their corresponding means. So our possible samples from our population would be 249, 2410, 245, 2910, 295, 2105, 4910, 495, 4105, and 9105. Now let's get the means of our possible samples. So we will just add the samples. 2 plus 4 plus 9 is equal to 15. Divided by 3, 15 divided by 3 is 5. That's why the average is 5. 2 plus 4 plus 10 is 16. Divided by 3 is 5.33. 2 plus 4 plus 5 is 11. 11 divided by 3, that's 3.67. 2 plus 9 plus 10 is 21. Divided by 3, it's 7. 2 plus 9 plus 5 is 16. So we divide it by 3 to get the average is 5.33. 2 plus 10 plus 5 is 17. Divided by 3, the answer is 5.67. 4 plus 9 plus 10 is 23. Divided by 3, that's 7.67. 4 plus 9 plus 5 is 18. Divided by 3, the answer is 6. 4 plus 10 plus 5 is 19. Divided by 3, the answer is 6.33. And 9 plus 10 plus 5 is equal to 24, and we divided by 3, the answer is 8. So that is for step 2. Now for step 3, we're going to create the sampling distribution table. So first, we will list the mean. We will arrange it from lowest to highest, and then we'll find the frequency and their corresponding probability. So our mean are 3.67, 5, 5.33, 5.67, 6, 6.33, 7, 7.67, and 8. Now we count how many 3.67 are there in our mean. And we can see here that there's only one 3.67. So we write in the frequency, there's one 3.67. And it goes on with 5, there's 1. 5.33, there are 2 5.33. 5.67, there's only one mean of 5.67. 6 has 1, 6.33 has 1, 7 has 1, 7.67 has 1, and 8 has 1. So we add it. 1 plus 1 plus 2 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1. Our total number of samples is 10. Now for the probability, we're going to count how many 3.67 appears out of the 10 samples. So the probability of having 3.67 as a mean in our samples is 1/10, 1 out of 10. Now having the 5 is 1 out of 10. For 5.33, the probability is 2 out of 10 since there are two 5.33. For 5.67, there's 1 out of 10. The same with 6, 6.33, 7, 7.67, and 8. We have 1 out of 10 for their probability. So this is how we create a sampling distribution for the sample means. So that's it for sampling and sampling distribution. I hope you learned something from this lesson. Always remember, have a statistic amazing day. Sampling distribution for our sample means.